Hi everyone, welcome to our video on applications involving rates of change, where we'll be focusing mostly on cost. Okay, so in this example it says suppose the total cost in thousands of dollars from selling X items is given by C of X equals 4X squared minus 10X. Let's find the average rate of change of cost for X equals 3 to X equals 4. All right, so we have the average rate of change. So be careful of these. So we have average rate of change and we have instantaneous rate of change. So the average rate of change, we have different formulas that we could use. I typically like to use the one that looks like this, f of x2 minus f of x1 over x2 minus x1. The main thing about this is you could really just think it's the slope. It's the slope equation, just using different ways to write our symbols. Okay, so what we'll do here is we're going to plug these in. So this x equals 3 would be really the x1, and then 2x equals 4, well, that's really the x2. So what we need to do is set this up as f of 4 minus f of 3 over 4 minus 3. Well, 4 minus 3 is really easy to take care of. That's just going to be a 1 in the denominator. I mean, it's in the bottom, so the denominator. So we can just set that up right now as 1, which really means all we have to do is just simplify the numerator, and we'll have our answer. Well, to do f of 4, so I'm going to use my blue color here. So f of 4, well, okay, so, and I used f as our generic one. So the cost function here, they used c. Well, this really is the same thing as f of x in this problem, if we would prefer to write it like that. Or it probably is better, though. Let's go back. So sorry if you're using ink. I'm going to go back and change these to c's. Okay, so that's our generic formula. And then now let's make it match to our equation. And the reason I wanted to stick with C instead of changing this to f of x is because we'll have other problems that involves profit, revenue, and cost. So I don't really want to start just saying everything's f of x because, well, I would have multiple functions that would be f of x and it'd get confusing. So instead I decided, well, let's just keep this as cost, and we'll change it to C of 4 minus C of 3. Okay, but now that we have that settled, we'll just plug 4 in. So in this blue parentheses, all I'm doing is plugging 4 into the x's. Okay, so I already did that on that portion, and so let's set up some space. So I'd have 4 times 4 squared minus 10 times 4. Okay, and so with that, let me fix that 4 a little bit. And with that, we could start to simplify it. But before we do, let's just go ahead. I'm going to set up the second portion as well. So let's do the minus, and then C of 3. Let's do that in red. So C of 3 like that. Let's make that, there we go. Okay, so C of 3 is just saying, hey, plug in 3 into those x's. Okay, so C of 3 has already been plugged in, and then now I need to do it for those. So 4 times 3 squared minus 10 times 3. And then now let's just simplify. Okay, so we still have our average rate of change. Now, because it's 1 in the denominator, I don't need to write that anymore. Let's just simplify the blue parentheses. So I have 4 times 4 squared is 4 times 16 minus 10 times 4. We could just do that as minus 40. And then minus, in the red, might as well keep the colors going. 4 times 3 squared would be 4 times 9. Minus 10 times 3 is 30, like that. Okay, and then now let's just still continue simplifying. All right, so we've got our average rate of change is 4 times 16 is 64. Minus 40 would be 24. And then we'll have minus. 4 times 9 is 36. Minus 30 would be 6. And so it looks like our average rate of change, 24 minus 6 is 18. Okay, so, and then we just want to, again, make sense out of this since it's an application. So it says the total cost. So this is a cost. So notice our top is about cost. And then these are the items that are being sold. So this means this is in thousands of dollars. So 18,000. I'll just write it in words. So $18,000 per unit. Okay, so that's the total cost in thousands of dollars from selling X items from X equals 3 to X equals 4. So it's about $18,000 per unit to go up 1 unit from X equals 3 to X equals 4. Okay, anyway, so that's all it is. It's just a breakdown, so it's just letting you know what the difference really was there. Okay, and then in number 2, it says find and interpret the instantaneous rate of change of cost with respect to the number of items produced when X equals 4. Okay, so note this number is called the marginal cost at X equals 4. So an instantaneous rate of change matches what would be called a marginal blank. So an instantaneous rate of change of cost matches the marginal cost. Okay, anyway, so we've got the marginal cost. I'm going to write it like this over here. So marginal cost is equal to the instantaneous rate of change, which has our equation, the limit as h goes to 0 of, okay, so instead of f of x, since we have a cost function, so they want us to reuse this cost function, let's set this up as c of x plus h minus c of x over h. Okay, so remember it's usually f, but because our function here is c, I'm going to use c. Okay, and then now it's our scenario where we want to simplify each of these. So we want to do this, but let's write on one more line. I'm just going to group them now with the colors, but it does say to plug 4 in, let x equal 4. So we can sub those in. Okay, so let's set that up then. Let's go ahead and keep this horizontal. So the limit as h goes to 0 of c of 4 plus h minus c of 4. Okay, and just to keep our colors, there we go. And those will be what I need to do the scratch work kind of for to evaluate. Okay, so let's do that scratch work. I hopefully have enough room on it. I'm going to put it way over here on the left. So let's do the blue portion where I'm simplifying this. Okay, so I'd have c of 4 plus h. Now we're just using the cost function that they gave us when they wrote out the problem, so it's right there. So all I'm doing is subbing out the x's with 4 plus h. So I'd have 4 times 4 plus h squared minus 10 times 4 plus h. Okay, so and just as a reminder, here is the cost function in case it's weird to look at it from way up high. Okay, so all I was doing is replacing those x's to get this expression. Okay, and then we would need to FOIL this out and simplify. Well, I'm going to save one step with the foiling. This 4 is going to be here. When this gets FOILed, so it does need to get FOILed. But when it does, I would have 4 times 4 is 16. I would have a 4h and another 4h, which would give me 8h. And then I have h and h giving us h squared. So that's a shortcut for foiling. So I take 4 and I take the first one and multiply it by itself. There it is. I take these two and multiply them and then times it by 2. So 4 times h is 4h times 2 is 8h. And that's what happens when we FOIL. If we did it the long way, that's what would happen. And then h times itself is h squared. Okay, and then we still have minus 10 times 4 plus h. And then we can simplify a little further by distributing. It looks like I would have 64 plus 32h plus 4h squared minus 40 minus 10h. So that's all the distributing. And then it looks like I can simplify two of those, or I have multiple like terms actually. So 64 minus 40 is 24. And then 32, so I did this one and that one. And then we have 32h minus 10h would be plus 22h. So there's those getting combined. And then we still have plus 4h squared. Okay, so that's all that first one. Okay, so let's go ahead and get the red one as well. C of 4 is 4 times 4 squared minus 10 times 4. And so 4 times 4 squared is 64 minus 40 is 24. Okay, so that one I could do in one single line. This one needed a little work. I'm just clouding them. There we go. Okay, so that is our, I'm going to kind of just block this off. so that was all of our scratch work to get this. So now let's plug it in. So in this equation, I still have this is equal to the limit as h goes to 0. The blue portion was 24 plus 22h plus 4h squared. And then we have minus, the red portion was just 24. And then it's all over h. Okay, and then looking at what we have, well, the 24 here in the blue and the 24 in the red would just subtract and make 0. So it looks like this becomes the limit as h goes to 0 of 22h plus 4h squared over h. All right, and then now, so we plug those in, we simplified this as far as we could. Now we want to factor and cancel. So the limit as h goes to 0 of, well, h is in common in the numerator's term, so I can take it out, and I'm left with 22 plus 4h over h. And then we can see that this h and this h would cancel. So we would have the limit as, one more step here, the limit as h goes to 0 of just 22 plus 4h. And well, now I can plug that h going to 0 right there, which would give us 22 plus 4 times 0, which would just be 22. Okay, so there it is. All right, so that's the numerical part of it. Well, the average rate of change is this, or not the average, sorry, the instantaneous rate of change, which matches the marginal cost. That's what this is. Again, we have cost up top, which is in dollars in thousands. So what this represents is, so 22,000. Oh, that's not how you spell 1,000. 22,000 per the unit sold, so per, because it are just items, whatever they said, so X items per item. Okay, and what this really means is it just, so marginal cost is kind of also known as the cost to make one more. So this is, it's saying it cost $22,000 to produce one more item when we already have 4 items. So when x equals 4. Okay, so for whatever, so often it's a linear cost, so like $5 per shirt. So however many shirts we make, it's still just $5 for each additional shirt. In this, it's abstract. It doesn't really say what it is still, but what could be happening is maybe it cost. So we saw an average. Let's go back to this. We saw the average rate of change to go from 3 items to 4 items as $18,000 per unit, whereas this is $22,000 per unit, and this is at x equals 4. So it seems like the more units that are being made, the more items being made, the more cost it will take. Okay, and that just might mean, hey, maybe they get heavier or something, and the shipping starts to add up. Who knows? Okay, so either way, that's all it really means, and that's all we had to do is to interpret it. Okay, let's look at number 3 here, where it says find the average cost function. So the average cost function is taking your cost function and dividing it by x. So it's got the c bar, and then this is how it's denoted. So the average cost is c with that bar on it. X equals c of x over x. And then we'll find and interpret the instantaneous rate of change of the average cost with respect to the number of items produced when x equals 4. Again, this would be called the marginal cost. It would be called the marginal average cost. Let's put that. That'd be the marginal average cost. So the C bar would make it the average cost. So sorry, that's a typo. So we'll fix that in the printout. Okay, anyway, so let's take a look. So first, let's just go ahead and find the average cost. Okay, so our average cost function is our C of x, which again, so our C of x, we can see, I'm going to scroll a little bit. Let's set that up. But our C of x was 4x squared minus 10x divided by x. Well, this is a good case because it looks like we could factor an x out of the top, and we'd have 4x minus 10. And then that way, the x's here just cancel. Okay, so we're left with, so kind of like how the h's did, those just cancel. Okay, so this becomes, let me just make it as an arrow. So our average cost is just 4x minus 10. Okay, so we found the average cost. I'm going to cloud it. That's not really the main answer. And then let's find and interpret the instantaneous rate of change of the average cost with respect to the number of items produced when x is 4. Okay, so this time around, so instantaneous rate of change is still our equation. The limit as h goes to 0. Now instead of f of x, it's this function, so c bar of x plus h minus c bar of x over h. Okay, so we can start to see it a little differently. Okay, but they also wanted to do it when x is 4 again. Okay, so let's change that x into 4. So we've got this limit becomes, let's go ahead and do it vertical and save that other half. Okay, so we'll have c bar as 4 plus h minus c bar of 4 over h. Okay, and then now let's plug those in. With this, let's see, so instead of breaking it to the side with scratch, let's just plug it in and see if you like this more. So I've got the limit as h goes to 0. All right, so I'm going to plug the 4 plus h into the x here. So I have 4 times 4 plus h minus 10, and then minus, in the red, plug 4 into this. That'd have 4 times 4 minus 10, all over h still. Okay, so this is a little easier to evaluate because there's no foiling involved. All I have to do is distribute the 4. So we'll have this becomes, so I've got the limit as h goes to 0. So let's just put the h down there. And then in the blue, distributing the 4, I'd have 16 plus 4h, and then minus 10. And then we have minus, everything in the red simplifies. So we've got 4 times 4 is 16. Let's go ahead and do that like that. 16 minus 10, and we can simplify. Okay, and so what's going to happen here? Let's simplify each of those. So I'm going to put this up here where I've got my limit as h goes to 0. Okay, in the blue, we can see it just simplifies to be 6 plus 4h. And then in the red, we will have just minus 16 minus 10 is 6. And then still divided by h. Okay, so 6 minus 6 is 0. Those cancel each other out. And we're left with the limit as h goes to 0 of 4h over h. Okay, so the 6 minus 6 zeroed each other out. And then h divided by h would cancel. And then I'd be left with just 4. So there's nowhere for h to go anymore. So I'd be just left with that constant 4. And we could show that in 2 steps still. So I have nowhere to plug h equals 0. So that means you're left with just the constant there as 4. Okay, so this is the average cost. So this is the instantaneous rate when our x is 4 for the average cost. All right, so this is still in dollars. So it's still 4,000, or it's still in thousands of dollars. So $4,000. Well, let's word it like this. The average cost, so instead of just the average cost to produce an item when x equals 4 is $4,000 per item. Okay, so this is giving an average cost to produce that item, whereas the one up above was the cost to actually produce just one item. Okay, so notice the difference. So the average cost is considering a bunch of them, Okay, and notice that with the phrasing, okay, so you have average rate of change, so careful. So that is the rate of change of cost between two items, two item values. So the average rate of change of cost is this. So this is, it's saying it costs $18,000 to produce really just one extra unit from 3 to 4. This is saying it cost $22,000 per item. So this is not an average. To produce one more item when X is 4. So to produce one more, it's 22,000. And then this is just saying the average cost to produce an item. So it's just an average cost. So these are good. Again, these are the actual costs, not an average. Okay, this is the average cost to produce an item when X is 4 is $4,000 per item. Okay, anyway, so a little confusing with the phrasing, but I hope this helps. So either way, whenever you get a rate, still just think it's something per something. So it's cost per item in this example. So the cost was in dollar amounts of thousands, and then per was the item. So something thousands of dollars per item is what these are interpreted as. So it's really just making sure we know the units well. Okay, anyway, so let's take a pause. Let's do one other video in this section, but I'm going to pause it and force you to quit out of this. Okay, so if you do have questions, though, please let me know. Otherwise, thank you for watching.